Hi class, today we are going to be talking about measurement concepts as it relates to chapter 5 of the text. Disclaimer, as you know. Okay, don't let this series of objectives overwhelm you. This will actually be a lot more simple than it looks. Most of what we are going to talk about will be 4 basic ideas: reliability, validity, reactivity, and the types of measurement scales. We'll talk about each one of these 4 basic ideas in some level of depth, so hopefully you can develop at least a basic working understanding of what these concepts are. I talked a bit about reliability and validity, I think, in the previous module, but this will be a discussion about that I hope will reinforce this concept. I completely understand that this is confusing stuff for a lot of people and is one of the most difficult things for research method students to wrap their brains around. I know that I had quite a bit of difficulty with it myself when I took this class, and it does take some time to sort of soak in, so don't worry if it does not make a lot of sense at first. As always, feel free to ask questions to your course assistant or to me over email, and we will do our best to help you. What I hope to do today is to talk about the different types of reliability, such as test-retest, internal consistency, and inter-rater reliability, and then talk about what construct validity means and break it down into categories of face validity, content validity, predictive, concurrent, convergent, and discriminant validity. We'll spend a brief amount of time talking about reactivity and why an understanding of what this is important in the development of measures of behavior. And finally, we will break down the 4 basic ways that we categorize measurement scales. So we will try to draw some distinctions between nominal, ordinal, interval, and ratio scales. Let's start out by talking about what reliability is. Reliability is how consistent a measure of behavior is. In a previous module, I think I used the analogy of using a bow and arrow and a target as a way to exemplify the difference between reliability and validity. So conceptually, if you shoot a bow and arrow at a target, let's say every time you shoot the arrow, it hits the same spot every time. This is reliability. The arrow always hits the same spot every time. It doesn't matter if the arrow hits the bullseye or if it hits the upper left-hand corner of the target. Reliability is only concerned with the relative consistency of where the arrow is hitting. So contrast this with a lack of reliability, which means that every time you shoot your bow and arrow, the arrow hits the different area of the target every time. This would mean something is really wrong because every time you take aim at your target, you're hitting somewhere different every time. The same thing is true for psychological or behavioral measures because we want to be sure that we're indeed measuring the same concept or the same type of behavior every time we make an attempt to. When we talk about reliability, there is this concept of true score. This is a concept that means ideally, if we are super accurate in our assessment, we should be measuring a specific behavior cleanly and accurately every single time. In the textbook, it talks about how IQ is measured by intelligence tests, and so I'll try to use that example and go a little bit beyond the book to hopefully provide a meaningful example. Ideally, when a person takes an IQ test, we want the test to be accurate and to measure a person's true IQ score. If they did not do that in a reliable way, then there would be no point in taking IQ tests because they wouldn't tell us anything useful. If a person takes an IQ test by today's standards and takes the same test over and over again, the statistical probability of them achieving the same score or close to the same score within just a couple of points is about 90 to 95%. So if you think about it, if you take an IQ test 100 times, 90 to 95 times out of 100, you will achieve the same exact score or very, very close to it. Obviously, this is a reliable measure of intelligence, and this fits perfectly with the next point, which is measurement error. Measurement error refers to the difference between a person's true score and the measured score. It only makes sense that a reliable measure would have very low measurement error. If we used an IQ test to measure intelligence and the measurement error would be a high score, then that would mean, statistically speaking, there would be a common and predictable difference between a person's true score and their measured score. That would be not good. A related concept that is important to understand in the same conversation is the Pearson product moment correlation coefficient, and we usually just call this Pearson's R. For those of you who remember this from your intro statistics course, you would remember that all that math that is involved in getting to an R score. And you probably remember that correlation values are limited to a range of +1 to -1. The closer we get to either +1 or -1, the stronger the correlation is. And the closer we approach 0, this means that there is no correlation between the two variables at all. In other words, two variables would be unrelated to each other if they're close to 0. In reality, it is very rare for there to be a perfect correlation between two variables or a perfect 0 correlation between two variables that are completely unrelated. And this is for a variety of reasons, including measurement error, like we mentioned earlier, but also because many variables are related to each other in at least a very loose or maybe just an insignificant way. Unfortunately for folks who might be visually impaired, this is going to be difficult to describe in words, but I will try my best. When a measure is reliable and it's plotted on a graph, we're going to see a narrow range of scores, and this would be characterized by a tall spike-like arc. If you compare that to an unreliable measure would have a much wider and flatter distribution and look like a flattened out arc. So keep in mind that the comparison that is being made for this type of graph is for people that have average IQs, meaning their IQ is roughly 100. A reliable measure captures these individuals pretty well and doesn't show too much error one way or the other. Whereas an unreliable measure would make a lot of mistakes and misclassify people as significantly above or below the 100 score, even if their true score was 100. One way that we measure reliability is by measuring the test against itself. And there are two really common ways to do that. The first is called test-retest reliability. Basically what this means in reality is that we have a person take a test and measure their score, and then have them take the same test again later and compare the later score to the earlier score. Then we correlate those two scores, and if the correlation is high, the test is said to have good test-retest reliability. If the number is not very impressive, then it is said that the test has poor test-retest reliability. So taking the example of IQ testing once again, if you took the test this year and scored 100, there's a high probability that if you took the test again next year, you would also score 100 because IQ is thought to be a relatively stable phenomenon. However, if you took the test this year and scored 100 and next year you scored 85, hopefully this means that the test you took was not very reliable. Another way to measure reliability is a format that we call alternate forms reliability. This means that researchers have two tests that measure the same concept but use somewhat different questions. Usually how this happens is a researcher will develop a large test that is equally divided into two smaller portions that are highly correlated with each other. For example, if a researcher developed an IQ test, they could take all of the odd numbered items and make that into test A, and then all the even numbered items and make that test B. And statistically, test A and test B should have a high correlation. So if you're thinking about these two different methods of reliability, you might be thinking about something that we call practice effects. So for test-retest reliability, we run the risk of a person learning how to correctly respond to questions the first time they take the test, and usually their scores on the second administration of the test would be slightly higher because they in fact learned something. And of course that is something that we consider when we do research in that way. This is one advantage of doing the alternate forms reliability method, but that has its own disadvantage. And the disadvantage of the alternate forms reliability method is that it is almost always the case that the two different forms are not perfectly correlated with each other. And this means that there's also a small chance that a person would get a different score on Form A or Form B, and then we would have to do some extra explaining and work to try to explain why a person got a different score on one form as opposed to the other. Another type of reliability is something we call internal consistency. What we're talking about here is the extent to which psychological measures or assessments are reliable within themselves. There are a couple of different ways to check this out from a statistical standpoint, and one way that we can do that is by looking at half of the items and correlating it with the other half of the items, similar to what I mentioned in the previous slide. Ideally, a split half reliability score should be very high, because if it is not, then that means that some of the questions that are posed on the questionnaire or assessment would not be related to each other in a meaningful way. Some intelligent researchers ask the question of how we make decisions about what questions go into one half and what questions go into the other half. And the more questions we have, the more complicated this gets. So of course, this is a really good question, and researchers found a way to do this using computer statistics programs that can do a whole bunch of calculations at once, more quickly and more easily, and they developed a method called Cronbach's alpha. This method looks at all possible split half reliability coefficients by dividing the assessment or questionnaire into all possible halves, and then comparing each one of those calculations to each other and creating an overall score. So again, an ideal score for a Cronbach's alpha should be very high. And when researchers are developing an assessment, sometimes they find specific items that may not be correlated with the other items very well. And so the researchers have to find a way to take steps to eliminate the items that don't fit in very well. So how they do this is they use a method called item total correlations. It basically subtracts one item out of the entire assessment and correlates that item with the rest of the remaining items just to see how well it fits in with everything else. If the item fits, we keep it in the questionnaire or assessment, and if it doesn't, then generally we throw it out and don't use it. Another way to measure reliability is the concept of inter-rater reliability. This is useful when we are making qualitative judgments about people's behaviors. Many years ago, ASU had a child study lab where psychology graduate students could just simply observe children's behavior and then rate those behaviors. These psychology graduate students could observe them and write these different types of scales to determine whether a child is behaving differently, difficulty socializing, being too aggressive, whatever the case may be. However, sometimes it is the case that one person rates a perception of whether a child is being aggressive, for example, differently than how another person perceives that child's behavior. And usually this is a problem because there's a misunderstanding about one person's perception of a behavior versus another person's perception of a behavior. But ideally, when we're doing behavioral observation, we want everybody to be on the same page, and we train the observers to be very clear on what it is that they're looking for. Ideally, the inter-rater reliability should therefore be very high. If the inter-rater reliability is low, then that means there's too much flexibility in how the observations are being perceived by the observer. If you're interested in reading studies where naturalistic observation or behavior rating scales are used, this is a common issue that's discussed in those articles. And if you take note of the statistic that might be in those studies called Cohen's kappa, you'll be able to examine how well the different graduate students or researchers agreed with each other about what they were observing. It will probably never be a perfect correlation, but ideally it should be close. As a final note, reliability is one thing, but this does not necessarily mean that a reliable measure is a valid measure. As I stated earlier, if I shot my bow and arrow at a target and every single arrow hit the upper left-hand corner, I would definitely be reliable. but I would not be valid in my archery skills because I would be never hitting the bullseye. So not only does this make sense for measuring psychological purposes that we need to be reliable, but we also need to be valid. This is a good opportunity to switch gears and start talking about validity. First, we will go over a broader concept of construct validity. In the general sense, construct validity is a sort of philosophical concept. First, you have to understand what a construct is. A construct is sometimes an idea, and that idea oftentimes has multiple parts. So let's take schizophrenia, for example. Schizophrenia is an idea that where psychologists will look for different components of schizophrenia when they're doing an assessment for schizophrenia. We might actually look for things like disorganized thinking, hallucinations, and delusions, for example. If we have an assessment that we think measures schizophrenia but doesn't measure for all the components of schizophrenia, then there's a problem with our construct. There's a problem with the way that we think about what schizophrenia is. The same is true for all kinds of other things, like take antisocial personality disorder, for example. There are a number of different types of behaviors and attitudes that make up antisocial personality disorder. And so the construct should ideally include all the things that we know are commonly seen, like disregard for other people's rights, willingness to break rules for one's own personal gain, and so forth. So as you can see, construct validity in terms of making assessments is really important because we want to make sure that when we're measuring something, we're capturing all of its components. Construct validity is broken down into other forms of validity that serve different purposes. The first is face validity. This is probably the weakest way to measure validity because essentially what this means is, does the measure at least look like it's measuring what it says it measures? This may not always be true. For example, the internet is full of all kinds of online personality tests that supposedly tell you something about yourself that is probably just a bunch of stuff that you already know. So the test might look valid, meaning it has face validity, but in reality is not really that informative or may not be particularly accurate. So let's contrast that with something that is meaningful but does not have much face validity. In the world of true personality assessment, one of the more complex personality assessments is called an MMPI. You don't have to know that for any of the exams or content of this course, but it's a great example because this test doesn't look like it's actually measuring your personality at all. Instead, it looks like whoever's responding to the questionnaire is just basically responding to a bunch of random statements with true or false answers. And in spite of the fact that it does not have any face validity at all, it has incredibly strong construct validity and is often used in all kinds of settings like forensic applications, FBI trainees, Department of Defense, and so on. So think for a moment about whether it is important for a measure to be face valid for any particular kind of assessment, and if so, why? And if not, why not? The next type of validity is content validity. In the textbook, it talks about depression measures to some degree, and if we truly want to have a good assessment for depression, the depression assessment must have the correct and adequate number of questions to assess the content areas we're interested in for depression as a construct. So for example, questions that measure things like irritability, loss of interest, perhaps suicidal thoughts, and so forth. If all the things that we know about that make up the construct of depression are included in the assessment, then the measure would have good content validity. However, if we had the same measure and it also maybe threw in a few questions that assessed something like schizophrenia, like hallucinations and delusions, then we would have problems with content validity because it's really unusual for a person with depression to have delusions and hallucinations. So content validity is important because it helps us to know what specific parts of the construct are needed in order to be thorough in our assessment. We don't want to catch 80% of what we know about depression. We want to know how we can capture 100% of the construct of depression. Next, predictive validity. I think this one is quite a bit easier to explain. What this essentially means is whether an assessment can successfully predict a specific type of outcome. For example, one of the reasons why people are asked about their undergraduate GPA when they are applying to graduate school is because we already know that a high undergraduate GPA is a strong predictor of success in graduate school. So in other words, undergraduate GPA has high predictive validity when the outcome is success in graduate school. There are lots of other things we can think about in this regard as well. For example, people who score more highly on a body image dissatisfaction questionnaire may have a higher risk of developing an eating disorder. And we can think of all kinds of other examples where something like this makes sense in terms of predictive validity. Now on to concurrent validity. In addition to what is described in the book, concurrent validity also refers to how two separate concepts or two different measures are related to each other. For example, if you were employed somewhere where you're required to do a self-assessment of your own job performance, and then your supervisor also does a rating of your job performance, assuming that these are done at the same time and were highly correlated, these would hopefully show concurrent validity. The difference here is that you are responding to your own questionnaire while at the same time another questionnaire is being completed on a similar concept. And the belief is that both of these sets of results will be correlated with each other. Convergent validity refers to the extent to which your own responses on one test would be strongly related to your responses on a conceptually similar test. So let's make an example. Two conceptually related measures that could be measured would be self-esteem and a measure of depression. Generally speaking, people who have problems with self-esteem are more at risk for depression and vice versa. So if a person with low self-esteem completes a measure of depression as well, there should be a correlation between these two concepts, and if so, this is convergent validity. Finally, discriminant validity. This is basically the opposite of convergent validity and can be thought of as divergent validity if that is more helpful. In other words, what this means is that your score on one measure should be different than your score on another measure that is conceptually different from the first. So let's make an example here as well. Using the depression example again, if you scored very low on the depression scale and then scored very high on a scale measuring perceived self-actualization, thinking about what you learned about Maslow's hierarchy of needs from Psych 101, if you are more self-actualized, then ideally you should be less depressed. So your score on one conceptual scale should be completely different from your score on another scale because they're conceptually different. Related to the concept of face validity is the idea of reactivity. Reactivity means that someone who has a certain level of awareness to the situation that then affects the outcome. A person might be behaving in a certain way because they know that they are being observed, or they are responding to a questionnaire in a way that changes their response style. It should come as no surprise that people's behavior can be different when they know they are being watched or assessed. Often this is because people tend to respond in ways that they think will get a positive reaction or maybe some other type of benefit. Obviously, people's reaction to being assessed or observed can be a threat to the validity of the measure itself. For example, in forensic practice, it is not uncommon for parents who lost custody of their children but who are seeking to regain custody. They know that they are being assessed and observed. They often paint an overly positive picture of themselves as if they have absolutely no problems at all, and obviously this is not true because everyone has problems, right? The issue here is that we have to be aware of their reactivity and how this affects the validity of the outcome. As far as research goes, this is also a problem for experiments in particular because if people know that they are being watched or maybe have some idea about the experimental manipulation, then they may change their behavior in certain ways that ruins the experiment. This can also be true on a survey study. If the questions themselves cause the person to have a certain type of reaction that might make them offended, angry, sad, defensive, or something else, this reactivity might negatively affect what it is that we are trying to measure. Oftentimes, psychologists have found sneaky ways of assessing certain ideas and behaviors without the participants actually understanding what the psychologist is looking for. But that sneakiness pays off because the reactivity is not affecting the desired outcome as much. Moving on, let's talk for a few moments about the types of measurement scales. This is a really important discussion to have to know what types of scales measure what types of variables. I think if we move on to the next slide and look at the table, this will make a lot more sense. The first type of scale that we will talk about is the nominal scale. This is generally used in situations where we're looking at something like categories that don't really have a numerical value. And there's not going to be any numerical value between categories that makes any kind of sense. So for example, let's think about eye color. There really isn't a numerical difference between people who have blue eyes versus people who have green eyes or brown eyes. Instead, we just have categories. The example given here is like left-handed people versus right-handed people, or introverts versus extroverts, but it doesn't necessarily have to just be two categories. It can be multiple categories. The main point here, though, is that there is no numerical way to really differentiate between these categories or assign any real value to the categories. The second type of scale is the ordinal scale. The problem here is somewhat similar because even though we might have a ranking system, there is not necessarily a way to know what the difference is between, say, first place, second place, and third place. All we know is that one thing is ranked above another. So, for example, let's say we're looking at marathon runners. A person who finishes in first place might be 5 minutes ahead of second place, but the difference between second place and third place might only be 10 seconds. So as you can see, the differences between ranks is not the same, but the important idea here is that one thing might be ranked above another. Another example, we know that Arizona State University is better than that school down in Tucson, but the exact value between first place and last place isn't something that's really measurable. It just is, and we know it's a lot. The next type of scale is the interval scale. IQ is a great example of this. The thing to remember for interval scales is that there is no true zero. Like for SAT scores, nobody ever gets a 0. And just like on IQ, nobody ever gets a 0. There are equal intervals between the values that is sensible and scalable. So, for example, the difference between somebody that has an 100 IQ and another person that has a 115 IQ is the same interval as the space between a 115 IQ and a 130 IQ. The same thing is true for something like temperature. The difference between 100 degrees and 101 degrees is the same difference as between 101 and 102 degrees. Finally, the ratio scale does have a true zero, and we can make a few more statements about what the numbers mean. So let's talk about how that works. If I run 100 meters in 12 seconds and you run 100 meters in 24 seconds, I'm literally twice as fast as you. Also, if I weigh 250 pounds and you only weigh 125 pounds, I'm literally twice as heavy as you. The same thing can't be said for interval scales because a person who has 100 IQ is not twice as smart as a person with a 50 IQ. We don't make those kinds of statements. Even though people try to make statements like that, it is factually untrue. Okay, so class, I hope that this is going to do it for this group of slides. Please let me or one of the CAs know if you have any questions, and please try to reinforce your learning by reading the text. Thanks, and see you next time.